Hey 7th graders, Miss Rogers here. We're going to do an experiment today with dry ice. So we've been talking about states of matter and how we have solid, liquid, and gas. And we're going to talk about the changing of those in respect to volume and pressure. So we've got dry ice here. It's going to sublimate, which is going from straight from a solid to a gas. We're also going to talk a little bit about deposition, which is how that gas can go back to a solid. So stay tuned for the experiment. So we're going to look at dry ice here. The reason why I have to wear a glove is because this is very cold, somewhere around -20 degrees Celsius. So it will burn your hand, burn skin if you don't have a glove. So if you take a look here, can you see the smoke coming off of it? Dry ice doesn't melt. This is frozen carbon dioxide, and it will not go to a liquid state. It goes directly from solid to gas. So as I'm holding it, you can see what looks like steam coming off. It's actually carbon dioxide evaporating, but it's not actually evaporating because that is when a solid or a liquid goes to a gas. So here, this is called sublimation. Sublimation is when a solid goes directly to a liquid. So we're going to put it in this little glass of water here, and you're going to see the bubbles. Those bubbles are caused by the CO2 gas coming through the water. So we're going to leave that sitting right there for a minute. So when we look at states of matter, as you can see, we've got this carbon dioxide coming off here. So what happens if I were to cut off the ability of that carbon dioxide to come out of the container? So we know that the difference in solid, liquid, and gas is the amount of space between the molecules. So when you have a solid, the molecules are closest together. When you have a gas, they're furthest away. So what would happen if we completely cut off the ability of this gas to be released? So we're actually going to look at that. We're going to put some more dry ice in this 2 liter, and we're going to do an experiment. So give me just a second to put some dry ice in here. All right, so we have this 2 liter bottle here. We've got dry ice down in the bottom. You can see this bottom is very, very cold from the dry ice being down there. So what we're going to do is we're going to pour this water in the bottle. So when we do that, you're going to see sublimation occur very quickly because of the reaction with the water. All right, so this gas is coming out very, very quickly. Obviously, it looks like a train. So what we want to know is what's going to happen when I screw this lid on. So the volume will not be able to change. So right now, this gas is able to escape. What's going to happen when the volume is fixed? Basically, right now, we don't have a defined volume because the gas is able to escape. So we're going to fix the volume and make it to where it can no longer come out of the bottle. So we'll pour a little bit more water in there. And we're going to fix this volume. I'm going to have to get closer to it.
How's it going to go? Up?
I don't know.
Out? Crap. I'm scared. I'm going to go here and hide.
You have the camera.
I know. Hey children, I'm hiding.
Here. It's still on.
Hey, hey, hey.
can tell, this bottle is completely destroyed. So what exactly happens? Because we fixed the volume, we continue to have gas sublimating from the solid dry ice in the bottom. When that happened, the pressure increased in the 2-liter bottle so much that it forced it to explode. But what would happen if, let's say this was, I don't know, some kind of metal bottle that could not explode? So we had a fixed volume at all times. Is that likely to happen? Probably not, but what if it did? So you continue to have these gas particles being made. As the number of gas particles increases and volume doesn't increase, or the thing doesn't explode, what would happen to those particles? So you're getting more and more gas particles in the same amount of space. So those particles are going to become closer and closer and closer together. As you make more gas particles, or gas molecules, those molecules become closer together, which means they're eventually going to change state again. So they're going to go back from the gas state back to the solid state.